This assignment, we are doing structure analysis, which is to determine the effect of load and moment on physical structure and their components. All structure that endure load, such as building, bridge, are subject to this type of analysis. Structural analysis establish the relationship between predicted external load and pin and roller that occur within the member. In this assignment, we choose this bridge structure as our model. We have to find the reaction force acting on this structure. And this is idealization model is to simplify version of the physical system or to get the better view of each system. By constructing a complete idealized model, it will show how the system works, where left side as a pin and right side as a roller.
As mentioned before, we use a beam bridge. As you can see, E is roller support for the bridge, and for this beam bridge, we decide to calculate the force and moment acting on the beam through point B and point D. So first of all, we need to draw a free body diagram or FBD for beam bridge as shown, which is this include all force acting on it, and these are used to show the direction, and it helps to visualize all the force acting on a single object. As mentioned, we want to determine resultant internal loading through point B and D. But before that, we need to find the support reaction for member CE first, as the value will be used to find point B and D. First, we change the distribution load to concentrated load and determine the magnitude of concentrated load. Then we determine the centroid, and then we draw the FPD with support reaction force indicate as shown on the slide. So we want to find E, then we use 150 multiplied 2 minus EY multiplied 6 equal to 0, and then we got 50 kilonewton. After that, we want to calculate the force at C. So summation Fx equal to 0 and Fy equal to 0. So we insert the value into equation, which is 50 plus Cy minus 150 equal to 0, and then we got 100 kilonewton.
At point D, the FBD length is 3 cm divided by 2 and times with 1 over 3, it will get 1 over 2. Next is the force is 1 over 2 times 25 times 3, and it will get 37.5 kilonewton. 25 we get from the kilonewton at FBD, which is 50 divided by 2. And next is total Fx equal to 0. Negative Fxd equal to 0 because the arrow against the direction. For total Fy equal to 0, 50 minus Fyd minus 37.5 equal to 0, which is Fyd equal to 12.5 kilonewton. For total moment is moment equal to 0, md plus 25 times 1 over 2 and minus 50 times 3 equal to 0. md equal to 150 minus 12.5, and it will get 137.5 kilonewton. At point D, the FBD length is 3 cm divided by 2 and times with 1 over 3, it will get 1 over 2. Next is the force is 1 over 2 times 25 times 3, and it will get 37.5 kilonewton. 25 we get from the kilonewton at FBD, which is 50 divided by 2. And next is total Fx equal to 0. Negative Fxd equal to 0 because the arrow against the direction. For total Fy equal to 0, 50 minus Fyd minus 37.5 equal to 0, which is Fyd equal to 12.5 kilonewton. For total moment is moment equal to 0, md plus 25 times 1 over 2 and minus 50 times 3 equal to 0. MD equal to 150 minus 12.5, and it will get 137.5 kilonewton. Next is point B. The FBD length from A to C is 6 cm and force is 30 kilonewton. FBD B to C is force at C is 100 kilonewton and B is 30 kilonewton. Next, total Fx equal to Fbx equal to 0. Total Fy equal to 0, which is negative 100 minus 300 minus Fby equal to 0, and Fby will get negative 130 kilonewton. Negative 100 and negative 300, it is because of the arrow against the direction. Next is total moment equal to 0. MB plus 100 times 3 equal to 0, and MB will get negative 300 kilonewton meter.
Hi, my name is Nashra Nurinisa Ahmad Pudelani, and I'm going to present the analysis of this assignment. From this assignment, we can conclude that the beam have internal force, which is there is tension and compression. Internal force is defined as a force that occurs within a system without any external potency. As a review, internal forces are the forces that exist within a body in order to balance out the external forces on that body. In order to calculate and investigate the internal forces, we must separate the structure into two separate parts, each with a separate free body diagram. From the EOE, at the point B, there are compression forces since the progresses down from the top surface to the bottom. At point D, there are tension force because the forces are pulling away from the object. An object with no net forces acting on it, which is initially at the rest, will remain at rest, are called no external forces. Besides, it is not necessary to apply force to keep the body moving as such. To conclude, a beam is a structural element that primarily resists loads applied laterally to the beam's axis. The internal forces are very important. Their magnitudes and directions are the deciding factors in the required size and the form of the structural components. Beams provide a stable load path at the building's base and supporting the weight of the building's roof.